Hello everyone and welcome to On the Spot STEM. Today we're going to be doing AMC 10B number 25 from 2018. The problem reads, let the floor of x denote the greatest integer less than or equal to x. How many real numbers x satisfy the equation x squared plus 10,000 times the floor of x equals 10,000x? So as you can see what I've written here, we'll use something called the fractional part of x, which is exactly what it sounds like. Basically, let's let x equal 7.2 for an example. So that means the floor of x would be 7 and the fractional part would be 0.2. So the fractional part of x is always going to be between 0 and 1 as how we defined it. And also, another good thing to note is that if we plug in x equals the floor of x plus the fractional part of x into the equation, we'll just get x squared plus 10,000 times the floor of x equals 10,000 times the fractional part of x plus the floor of x, which we can cancel out 10,000 times the floor of x from both sides, and we'll just get x squared equals 10,000 times the fractional part of x. And, well, remember what I said when x is between 0 and 1? That means that x squared must be less than 10,000. Which if you solve this, you'll get that negative 100 is less than x, which is less than 100. Okay, so now let's draw the equation that I've boxed in blue. So drawing the x squared is easy. You just have a parabola. But drawing the 10,000 times the fractional part of x is much harder. But basically, it turns out to be a bunch of straight lines with holes on top. So in this graph, you see the parabola, that's x squared, and you also see the lines representing 10,000 times the fractional part of x. As x goes from 0 to 1, for example, the y value of the floor will go from 0 to 10,000. As x goes from 1 to 2, same thing, 0 to 10,000, and so on. So now, let's consider the graph of y equals x squared minus 10,000 times the fractional part of x for some value k to k plus 1, where k is an integer. And let's also let k be between negative 100 and 100. So if that's the case, that means that x squared is less than 10,000. So what that means is that when x is equal to k, the fractional part, since k is an integer, is 0. So that means y in this case is positive. But as x gets closer and closer to k plus 1, the fractional part gets closer and closer to 1, which means that since x is less than 10,000, that means that y is negative. So at some point, y must have been equal to 0, which means that there must be one solution. We can do this for k equals negative 99, negative 98, and so on, all the way to k equals 98. But what happens when k is equal to negative 100 or when k is equal to 99? So when k is equal to negative 100, scrolling back to our equation over here, we can see that we basically, when k is equal to negative 100, we'll get y equal to 10,000. But when k is just short of 99, we'll get y equals 99 squared minus something really, really close to 10,000, which is obviously negative, which means that the case where k is equal to 100 must have a solution. But what about k is equal to 99? Well, again, it starts off positive with x squared equals 99 squared minus 0, which you get that y is equal to 99 squared. But when x gets to 10,000, x squared minus negative 10,000 of x will not intersect because when we take x equals 100, x squared is 10,000. But 10,000 times the fractional part of x can never be equal to 10,000. 10,000 times the fractional part of x is never equal to 10,000. So that means that there must be no solution, which means that k equals 99 does not work. So basically, we get the solutions k equals negative 100 all the way to 98. And if we count all of them, there's just 199 solutions for k. And we go back to the answers and we see that 199 is just C, and we're done.